Alright, we left off on a 3-wire control circuit. So the advantage of a 3-wire over a 2-wire allows additional switches to be added. When we use these momentary switches, these are called momentary switches. So here on the side it has a spring, makes momentary contact. When we release, it releases. So it only makes that temporary signal. So on this one is green, that's start, red is stop. It's just a piece of plastic that you can cover. So they're all the same. Okay, on one side it has a red side, and that is your 12 and your 11. On the other side it's green, and that would be your 23 and 24. Others have 1, 2 for the stop, 3, 4 for the go. So depending on the manufacturer, numbers can change. It's just numbers. It's that last number that we're looking at, the 1, 2, the 3, 4. Okay, so these two, there's no difference other than that little red cap. Auxiliary contacts. So on your starter, it has an auxiliary contact. This one has an auxiliary contact internally. Okay, that's why they're called auxiliary contacts, or sealed in contacts. They're inside here. So when power comes across, and like I was showing on the video from that I sent out Friday, when I had these up close, you have the 3 and the 4, and then the A2. So the 3 and the 4 is your normally opens, and that's where the contact's at. So once you hit that start button, it sends power across. Well, once I hit the start button, the start button here, because you can see right here, I got 1 coming in, 2 going out, and here's my connection on the 2. I'm coming to the auxiliary contact, which is in here. That's at 3 and the 4. And then it comes off the start side on the switch. So I'm going to come in on the 1, come off the 2 to go to my switch. Off the 2 here, I would come across to the number 3 up here. And then that comes down to the auxiliary. Okay. And then it also comes to the number 3 on the green switch on the start. And then off the 4, I come across and it goes to the coil. So off the 4, my coil is down here. This is 120 volt, 110 volt, 120 volt. So my neutral would be A1, and my off the 4, I come down here. I'm also going to go from the number 4 here to the number 4 here. And that's how it gets hot. So what happens is when you push this button, when you push the start button, it comes to here, it sends power, this closes, that auxiliary contact, that sealed contact that's in here, oh, there's electricity, boom, and it closes. So this goes from being open, this is always closed, this goes from being open to being closed, and it closes. Okay. This is a wiring diagram, and this is an elementary diagram. They're both the same thing. This is showing within the component. Okay, this is the side. Okay, the difference between the two is this is somewhere else, and this is within the unit itself. So they're no difference, just a wiring diagram. Okay, this is the one that I always put up on the board. Got my hot coming here because this one is 208 or 230 volts. Comes across and feeds this side. Okay, even though it says AM here, it's not the motor, it's the coil. But the thing is once this coil closes, guess what? The motor comes on. So that's why they use M. Some of them use a C, some use an M. Okay, so auxiliary contacts are sealed in. Push button switches has momentary contacts. And the 3-wire allows you to add more switches compared to a 2-wire. The 2-wire, if I have another switch, if I had another switch here, well, the thing is I have to close both of them. So if I put 2 switches in series, it doesn't do me any good. So that's the problem with this 2-wire. You only have one means to open and close it. You only have one means to open and close it. I mean, you could come across over here and put one in the remote location, but that's the last thing you want with one of these is you turn this one off, somebody walks over there and turns that one on, and you don't even know it's there. So always, when you got a two-wire connection, don't put more than one device. One remote device to turn it on and off. When you're using a two-wire, don't try to put any somewhere else, because if you don't know it's there, and you turn the motor off going to work, and there's a switch somewhere else, okay, that you don't know about, that could turn it back on. Somebody else could turn it on you. There's things you can do, but I wouldn't advise it. Now, let me get the book real quick. And again, the momentaries are spring loaded and they return. So as you push down, it makes contact. As you release, it goes back to the original position. The starter's auxiliary contacts are referred to as a sealed in contact. So again, I talked about that. They're sealed in. So this contact right here is within the starter. It's here. This contact is here. Okay. This one comes in here. If I had an auxiliary like this one here, where I have this tied in, okay, that here would come over here. This doesn't have overloads. If I have overloads, I got to get something like this, or another one where it has a physical overload. These are electronic. So if I have it here, I'd have to tie this in. Do I want it normally open, or do I want it normally closed? And it gives you both options on this. Okay, it gives you both options on this. Normally open, normally closed. Okay, so you set your trips wherever you need them, according to the math, 125% or 115%, depending on what type of motor you got. And again, okay, this one's normally closed, so you would go to the normally closed. You would go to the NC. Okay, so normally closed, you would go to the NC. If you want this open, then you go to the NO. Again, diagram between the two, they're both the same diagrams. Oh, well, how does this work? Okay, again, well, I got the drawing here. When I push that start button, it sends current. It's getting this voltage, and you can see I got it here to here, and here to here. So I got a hot here, hot here. It's not hot here. I'm sorry. It's hot here, but it's not hot here. So what happens is when I hit the start button, this contactor sees voltage on both sides and it closes. Bloop, closes. So now my voltage comes off of from here, comes down this way, goes across. Once this closes, goes across, goes to here, maintains that coil energized. Remember, when the coil is energized, it closes, and it remains closed as long as it stays energized. Okay, when I hit the stop button, okay, you can see right here, when I hit the stop button, now from here down to here, voltage is removed because I'm opening the switch. The stop opens it, the start closes it. So as soon as I hit the stop button, I push the stop button in, it breaks that contact, it loses the voltage. This sees that voltage is gone, and the contact opens. Okay. The advantage over this and the advantage of this over a two-wire, you leave the switch on, power goes off, power comes back on, guess what? The motor's coming back on. Or you're working on the motor and you forget to turn the switch off, and you walk over to turn that breaker, guess what? That motor's going to come on right away. With a two-wire, the only way, on the three-wire, the only way this motor is going to turn back on, the only way this contactor is going to close is you go over there and you hit the start button. Again, once this auxiliary contact loses power, it turns off. Once it loses power, it turns off. So there's no way that power comes across. So the only way you're going to be able to turn it back on is by pushing the start. The only way you can turn it back on is by pushing the start. So the power is interrupted on a 3-wire circuit, not automatically restart the motor when the power is restored. A 3-wire circuit also provides low voltage protection. So it provides you low voltage protection. One of the questions in the assignment number 2 was, what doesn't a 2-wire do? It doesn't provide you low voltage protection. It says a few cycles of low voltage will cause the starter contact to open and stop the motor. This prevents a motor from trying to run on low voltage, a major cause of motor failures. Alright, so if there's a low voltage sensing it can give you. Let's say you have a problem somewhere and your voltage drops. Okay, this will help also open it up. So the voltage is too low, the contact may not hold. So contact is 120 volts and all of a sudden voltage drops under 100. Guess what? The contact could also release. Guess what? You don't want the motor running on that low voltage because it could damage the motor. So that's what the low voltage protection is talking about. That says voltage circuit. Controlled circuit voltage source. Okay, so operates at 120 volts or less usually. Sometimes we're using, let's say, 480, 536, 580, whatever it may be. So we have a higher voltage present to run these motors. So how do we fix this? How do we get, if our contactors are 120 volts or 36 volts or 48 volts, 120 volts or less, how do we control this? Well, we can put in a transformer to reduce the voltage between the motor circuit and the control circuit. Or operate a control circuit from a separate source. So this was, we talked about this on the last time, and there was a question that you had. So you can either bring in a circuit from outside. So you know you got lighting in a room, and your light is 120 volts. Well, you bring that 120 volts down and you control it. You know, or you set up a transformer within your motor starter, and then reduce the voltage so your stop-start switches are at 120 volts or less. Your contact, your coil is at 120 volts or less. So it's all according to whatever voltage you want for the equipment you're using. These voltage handle up to, these switches are good up to 220 volts. So on figure 1411, let me see if it's on here. So here we got 1411 and 1412. So here's our primary voltage coming in. This is coming to the motor. We're coming off 2 hots at 480 volts, going to a transformer. Here's our fuse. Remember, we got to protect it. So here's our fuse, and now we run our stop starts. So this would be 1 hot going that way, and this would be the neutral going that way. Here's our ground. Okay, so this would be the neutral, 120 volts. Ground if used. Okay. And then we can also bring a separate source. Bring a circuit from somewhere else, 120 volts, and bring it in. So we bring on a circuit. Here's the stop starts. Goes into our auxiliary contacts. Okay, goes to our motor or coil. Say this is our neutral coming in, and on this contactor here, it would go to the A1. And then coming off of here, this goes to the 3, and off the 3, or is it right here? It goes to the contactor. So this is on one side, my 3. The way I draw it is I put 1, 2, 3, 4. So from here I'm going to come down, go to my 3. And from here I'm going to come down and go to my 4. Off my 4, I'm coming down and I'm going to my A2, which would be that auxiliary contact. Okay, so as long as once the power comes across, and then since that power going across here, because this will bring it down to this way. Once you hit the start, the voltage comes this way and this closes. Okay, so I always use this as my 3 and then this as a 4. The reason I do it that way is because of these contactors that I use. They're inexpensive, and they're easy to use. So that's why I buy these. The bigger ones that I have is same thing, no problem. You can come off the hot, go to your transformer, and then if you have a neutral present or you're putting in a transformer, you're coming into the other side of the coil. If your coil is 120 volts or 220 volts, and say I got 220 volts, so I don't have this ground. I got 120 that way and I got 120 this way. Okay, so I have 220 volts because my main coil is 220 volts. Okay, I bring one hot, go straight to the coil. If it has auxiliaries, it's in series through the auxiliaries because it's always closed. You go through the auxiliaries and you come to here. Okay, that's here. Oops. Normally close. I got 95 and 96. So I can bring in the 95, go out the 96. This will always be on. Okay, if this trips out because the motor's getting too hot, this will trip out. Okay, all you have to do is just hit that button to reset it. The little red button on top. That's your reset button. If this trips out, all you have to do is hit the reset button. Before you do the reset button, make sure you check to make sure that your motor's good. If somebody else says, oh no, everything's fine, it just needs overloads. No. Get your tester out, hot the ground, hot the ground, hot the ground, hot the hot, hot the hot, hot. There's more to hot the ground. Okay, make sure the motor is not bad, and you can have this thing blow off the wall in front of you. It happened to me because I listened to somebody else, and they were in a hurry to get the thing going, and I was in a hurry to get the thing going because at the end of the day, and I listened to somebody else. Luckily, I had the cover on, so it didn't affect me much. It didn't give me a headache for about a week. I think I had a concussion that time. Reversing motors. Okay, reversing motors. This says it is often necessary to be able to run a motor in a forward and reverse. Motor direction can be manually reversed by switching connections. Some motor controls can reverse direction automatically. So you can use a switch. You know, all the switch does is you hit the stop button, hit a switch, and it just reverses two hots. Yeah, I got a here, and then these are coming this way, and then instead of putting them this way, I do it this way. So now the motor goes in reverse. Not a good way to do it. It's always to have a full voltage reversing starter, and it has interlocks that doesn't allow one from the other to start. Okay, so sometimes you can use overloads to protect it, but you only need the overloads on one. So you're gonna take care of on reversing the motor. Okay, if you have reversing AC motor, switching the line connections. So what does that mean? You can see here that I got line 1, line 2, line 3, and then they brought line 1 here, line 2 here, line 3 here. So they still got 1, 2, 3, 1, 2, 3. But let's look on the forward now. I got 1, 2, 3. Now they came 1 to 3, 2 to 2, and 3 to 1. So they're reversed number 1 and number 3. Okay, on the T side. So all they did is reverse these two hots to here. So they got these two and reversed them here. So when they hit the start button, it would close this and the motor runs forward. The way we had it when I was working in the meat processing plant, slaughterhouse, we had a green, a blue, and a red. So you hit the green to start it, and the green was forward. Okay, go to stop, then you hit the blue button, and it would run in reverse. Okay, because there was an auxiliary contact that wouldn't allow to go from green to blue. So I had to turn it off, disconnect this, before that red button would do anything. So if I hit the blue button, even while it was running, I hit the blue button, it wouldn't do anything. Why? Because I had to physically stop one to turn the other one on. we had the meat the mixer, the meat grinder. So it would mix the meat, and then when you hit it in reverse, that way you dump all the meat in, and it had a door, open the door, and it would reverse the motor. So now it starts to run the blades in reverse, and it pushes all the meat out of the vat. Okay, so that's how you do three-phase. Single-phase motors can be reversed. It says single-phase motor, single-phase three-wire motors can be reversed by switching the line connection. For three-phase motors, any two of the line leads can be switched. Normally 1 and 3 are switched. Okay, so that's what they did here. So here's 1, here's 3, and he turned around. Now here, number 3 is number 1, and number 1 is number 3. This is a full voltage reversing starter. Has two sets of magnetic contacts within the starter enclosure. One set of contacts makes the motor run forward. The other set of contacts causes the motor to run in reverse. So you can see it says EF. So this is my forward, because they're switching these two wires. Now this is my reverse. So you hit the stop button. Again, when I was telling you I had the 3 switches, so hit green, it'd go forward, and hit stop, stop it, then hit the blue. Then I would hit the blue. Now all of a sudden this one closes. Now it starts to run in reverse. Every once in a while you'll put motors in, not looking that it's reversed. Go back to the... So let's say you got a motor, and your direction of your motor is that way. The direction of the motor you need it to run is that way. You power it up, you hook it up, all of a sudden the motor's turning this way. Instead of turning that way, it's turning this way. What do? You come over here and you just get 2 of these wires and switch them. Okay, so all you got to do is get 2 wires and switch them. And the book says 1 and 3. Okay, do 1 and 3, black and the blue. They're already on the outside. So just switch the 2 wires. That'll get your motor turning in the right direction. I've had it many times when we get motors. We're changing out a motor, and a lot of times you always had an arrow. You know, the motor's burnt, so we can't check it. But a lot of times, the engineers that have worked in the area, what they did is it would mark direction of the motor turn, or direction of whatever the fan that is turning. Okay, it needs to go clockwise or counterclockwise. So they would have it labeled. So all of a sudden, we go in there, the motor burned out. We change the motor out. We hook it up exactly the same. Okay, all of a sudden the motor's going in the opposite direction. Okay, not all windings. We have that problem with transformers. I changed out the transformer, got everything in, and got changed out the transformer. But luckily, before we changed out the transformer, we took a rotation meeting. We had a smaller transformer. We changed it out to a bigger transformer. We're adding things. So I took a rotation reading. Which way is the current turning? Do the same thing with the motor. Check your rotation power. Okay, power's going in one direction. You should be able to get it. How it's hooked up. Take your rotation, see which direction your motor's turning, your rotation is turning. When you hook it back up, make sure your rotation is the same way. But in transformer is more important, because the thing did have about 10-15 motors. If the rotation was wrong, so we had to switch 2 wires, guess what? All those motors on there might have turned in reverse. Now we have to go back and change out. It's easier just to do it at the transformer. So changing rotations, checking rotations, it's always a nice thing to do. Reversing DC motors, reverse connections of a field armature winding for a shunt wound and a series wound. The armature is up at the front. And then switch connections for certain lead wires for compound wound DC motors. It's just like you get a battery. If you have a tester at home, put it on DC and put your black lead on the positive and put your red lead on the negative. It's going to give you a minus whatever that voltage is. But you turn around and put the red on the positive and the black on the negative, and it'll give you a positive voltage. So all you're doing is changing the rotation. You're changing, it'll read the voltage. A tester, I'm going to go to the tester real fast. So your tester will read the voltage, but it goes in negative. Why? Because it's reading it backwards. So with these motors, it's just a matter of switching your positive and your negative. And it would help switch rotation on a compound wound DC motor. Okay, when it has an armature field, you have to change the armature windings. Sometimes it's the direction of the brushes, you know, which brushes. So you have two sets of brushes. So one brush is pointing this way and the other brush is pointing this way. Okay, so this one de-energizes and energizes this one. Now the motor turns in reverse. Why? Because your polarity changed. It's just a matter of changing your polarity. Motor control circuits, MCC. So an MCC is a motor control circuit. These motor control circuits, the MCCs, we use them to power up a lot of motors. This is often several motors are controlled from a central location called the MCC. An MCC contains a group of starters. MCC structure is made of vertical sections and buckets. I remember I showed you, and we did electrician 2. I showed you the pictures of buckets that I had, and that's how I was showing you the buckets. The buckets go inside an MCC. Just talking about I don't say it's got MCC structures made of devices in MCCs. That's just your reversing. Devices in MCCs. MCCs located where power supply center or central location. So a lot we had when I was working at UCLA. Our MCCs, like for all our motors that are on the roof, we had our MCCs were on the floor below it, or it might be 2 floors down, and then from there it went up to the motors and all the controls are there. At the motor we had either a disconnect or we had a switch to turn motors on and off depending on the voltage or whatever they were, 3-phase, whatever. So we had a control area where we could check. A lot of times it was easier for somebody to go in there, okay, because it had lights on it. So they can check, is it on or is it off? MCC located with power supply, combination starters. The combination starter normally used with the motor control center. The MCC can also house feeder taps for remote equipment other than motors, such as heaters, lighting panels. Each control unit, called the ground out unit, is the modules independent from the other modules. Okay, so let me see if I got a picture on here. They're talking about the draw out unit. There it is. So the draw out unit is these buckets. So these are all individual. So they have nothing to do with one or the other. Yes, I got a bus system that's feeding all this. I got a main feeder coming in that feeds all of these, but I can pull this one out. So if I have to work on this one, guess what? I can pull it out to disconnect. It's got a screw, just get it, and you rack it out. Okay, so this is your MCC, so you can control. So you can see they got 100 horsepower, 20, 20, 10, 10, future, future, future. So on the future they got 3 different sizes. On the future they got 3 different sizes. Okay, where it says 3 times, 4 times, 2 times, I guess must be the size. Here's 10 times bigger. But it allows you to get so much. This can be divided in case you have to. They do make dividers, and you can divide these into 2. Some of these you can divide into 2. Wheel under has 1 door. It's a matter of changing the door, changing the inside, and you can make your connections. So motor control center, I'm trying to find a picture in a bit. So it has a combination starter, so it has the starter, the overloads, your stop starts. Sometimes they're on the door, they're not at the motor, they're on the door, where they might be remotely located within, and that's what these allow you. You can have the stop starts on the MCC and have a remote somewhere else, like you got an exhaust fan, or you have a fume hood where somebody can go do work, and you have an exhaust out of that area because you're working on toxic fumes. So they could have a turn on, a turn off. A lot of them, we went in there and we took that out because we didn't want anybody going in there forget to turn it on. So we had them running 24/7. So that way we didn't have to worry about somebody coming in there, coming in at 2 o'clock in the morning, and because he's got a wild idea to try something, he goes in and it works, forgets to take the exhaust fan on, gets overtaken by fumes, drops, and there's nobody there at 2 o'clock in the morning. Okay, so they ran 24/7 because sometimes it would work and they leave stuff there. So this allowed, it was a safety consideration. So you have the control unit, the module. Each one is independent. We call them buckets. So one of the little terms is a bucket. Includes disconnect device, magnetic starter, and a lockable handle. So the door, to turn it on and off, the breaker that turns it on and off is usually what holds it down. It has a screw, but you can turn it on and off. You can turn each one off independently from all the other ones. Motor control center, an assembly of one or more enclosure section with a common power bus containing motor control units. MCC design consideration. So when you're designing one, okay, space opens for future components. The bus, so the bus that's coming in there is all sized on the fault current. What's a fault current? Well, you figure your size, your amperage. If there's a fault to ground, your ground fault, okay, resistance and current and everything else, you size it to carry the fault. The last thing you want is this bus melting on a ground fault, on a fault. And bus bracing. NEC section 11026 for minimal clearance. So what is the clearances that you have to have? And that is on Article 11026. Okay, there's a motor control center, motor control unit. So within a unit itself, here's the disconnect. So it's going to have a breaker or fuses, and the bucket usually pulls out, so you not only turn it off, but you can pull it out so you can work it, and it kills everything. It also kills the buckets. Remember those pictures that I showed you, the guys that were working inside of one, it blew up. Okay, two guys trying to work in an area that big, and it blew up in their face. Okay, so here it comes off. They're bringing in our power. They're doing the stop starts. So here's the stop. Going to the start, 2. Going to the contactor. And then here's going to the other side of the auxiliary. These 3 here, that is our contacts inside of here for the power. So when this contact closes, power comes down, goes through the overload, and goes through the motor. Okay. This here is my auxiliary. The 2 and the 3 here is my auxiliary. And then here's my my overloads. The other contactor on my overloads that's normally closed. Okay, and that comes off of number 2 right here. Okay, and it goes to the coil. The circle right here is the coil. Here's my other auxiliary, comes off the start here and here. So this one, these 2 wires come in here. One comes this way to here, and the other one comes here, goes to the coil, and it comes to here. Okay, you can either have them here, you can have them in the coil. It really doesn't matter. This sees voltage going across, and it's going to stay energized and provides power to that coil, and the coil contains. Okay, so what I just pointed out is this 1. Here's that 1. This number 2 going across here, and it's coming to the auxiliary. Okay, this one isn't normally closed. Okay, this one they're showing it on. If that's closed, power's coming across. You have to be careful with that. Yeah. Up here showing it open, down here showing it closed. This is the wire diagram, and this is the elementary diagram. Oops. Oh well. Maybe I should put in motor control center. there's the motor control center. As you can see, it has a disconnect to turn it on and off. Oh, here, this was bigger. So it has a disconnect to turn it on and off. So there's on, green's on, red's off. That yellow would be the trip. This one has stop starts on it. It has lights, is it running or not? Okay. Sometimes it may have a key. So sometimes it's just feeding. I've seen some where they'll have an area and they'll have a panel where they're feeding also receptacles and lighting in a certain room. So we have a fan room. They bring power into the fan room. All the power for that fan room comes out of the MCC. The lightings and the receptacles come out of the breakers. Small exhaust fans or small motors where they're always going to be on or something, you know, 120 volt, 4 or 5 amps. They'll come off and they'll have it on the panel. But this is an MCC. These are called individual buckets. These are the buckets. And there's a couple of different varieties. And again, these all changed. These all change, so here's the actual buckets. So you can see that they do have spares. And then here's your contactors, your controls, anything that has to do with that motor, they're in here. Okay? This one's Allen Bradley. So there's quite a few people that make them. So you find one that's accordingly, or if it's already made and it's already there, or the blueprints already show you what's going in. It's what you do, what you put in. Okay, I'm going to send out an assignment with this one. I'm going to send an assignment out with this one, so just like I did yesterday. This is today's assignment. Some people haven't turned in yesterday's assignment yet. I'll release the PDF and the test tomorrow. Thursday, I'll be doing the Zoom Thursday night, 7 o'clock. So, see y'all then. Y'all have a good one. Stay safe.